Assalamu alaikum wa rahmatullah. Um, Welcome everyone. I want to present today my paper to you. So let me now make it full slides. Okay, so the title of my paper is in CRC Conference 2026 is Evaluation of Hybrid Deep Learning Models for Anomaly-Based Fraud Detection in Digital Banking. And my name is Mohammad Salim. My supervisor name is Nazhatul Hafizah Kamarudin and uh, Dr. Mohammed Kamrul and Mr. Omar also are co-authors in this paper. I am a student, PhD student in Faculty of Information Science and Technology in UKM. So this is also part of this paper is also related to my PhD work. The problem, as you can see in this slide, just like you can imagine, like when training a model this paper is focusing on comparing some hybrid deep learning and machine learning models, okay, on a specific data set, which will explain in this presentation. Okay, so imagine like when training a model on transactions from January to December, but randomly mixing in some December transaction together with so when you do this training for the model for, let's say, from December to January and mixing these transaction together during the training and the testing. Okay, so this will cause a problem usually, which will happen by a random split, which will mix up the transaction data and make the model maybe, let's say, training not very good in detection. And most of the papers are using this, what's called random split. Okay, they are mixing the data together and could be using, for example, January and December, both of them, on the training phase and on the testing also phase. So in this case, we are not considering this kind of training will not consider evolving threat of these threats or frauds, right? And this is like in the literature, as you can see, most of the papers were getting F1 equals 0.88 until up to 91. So basically because of this kind of training, random split. So in this study, we are trying to make a more accurate temporal comparison by using three hybrid deep learning models evaluated under identical leakage-free temporal conditions and also a quantified performance gap, empirical measurement on the gap between a random split and used by literature and what we used here in temporal split results. Then also explore the literature and experiment link to make direct connection between literature claims and our experimental confirmation. Then we verify the baselines, establish like baselines for future drift-aware fraud detection research. Since the drift-aware is focusing on like considering these threats or frauds are evolving over time, and the random split is not enough to work with these kind of frauds. Data set and temporal split design. So the data set that we use has 28, 284, okay, almost like transaction and 192, there were the transactions, and this is the fraud cases, which is like around 0.17 percent. And this like there were 13 features, okay, including the time and the amount for this data set, European data set, it's called. So the training on what we are going to use is 17, 15, 15. So 70 will be for training of the percent of the data, then validation will use 15. The other 15, then the rest, last 15 will be used for testing, just to make sure that we are following not a random split design. So this design is called temporal split design. So we are starting from the old, then we are going to the newer for validation, and to the newest part will be for testing. Okay, so sorted according to the chronologically by transaction time, and no shuffling, no future leakage into training. So the smart here, oversampling applied only to the training set, okay? Because like validation and testing retrain their like natural imbalance class distribution. So 56 and 52 fraud cases there were in the training. So that's why we need to use the smart oversampling just to make the percentage of the fraud cases, much higher. Or since like we call this one imbalance class distribution, when you have very low percentage of frauds. The model compared here, CNN, LTSM, attention. These are the deep hybrid learning models used for fraud detection. And the second one, CNN, GRU. This one also efficient for sequential modeling. And the autoencoder LSTM, this one for autoencoder is unsupervised, and plus the LTSM classifier on the encoded representation. So this is what we tested, these three hybrid deep learning models that show up again and again in recent literature. CNN combined with the LTSM and attention. Then CNN combined with the GRU and autoencoder. Finally, and the LSTM pipeline. Just to keep ourselves like honest, we also run two classical baseline logistic regression. These are two of them, which is a logistic regression and the random forest. Okay, trained on the exactly the same data. That comparison just turned out to matter a lot, and you will see after a while. Okay, so as you can see in this diagram, these are the actual numbers for the performance after we did the experiment under the temporal protocol or temporal method for training. Among the hybrid deep learning models, the CNN, GRU came out on top for F1, a higher one. Then of this one, the percentage, almost 67. Then if you look at also at the random forest, so it actually beats every single which is like machine learning, this one. Beat every single hybrid model, hitting like this one. And that surprised us at first. And we'll explain why it happened in after a while. All the three hybrid deep learning models, caught exactly the same 39 out of 52 fraud cases. This is what they caught, and which turned out to be an important issue for us to talk about after a while. So this, as you can see, the diagrams generated by Python after the test for each one of these tests, okay, for the detection of the frauds. So, and here also the headline like results of this whole paper. Papers using random split. Okay. Uh, so these papers, for example, this paper using a random split reports F1 about like 90% under our honest also temporal protocol. The same style of model only reach about 63. Then, which is like 23%, like a drop. And that drop in F1 just from fixing how we split the data the way that we did the training and testing and validation. Nothing about the models changed. This tells us the field has probably been overestimating how well the systems would actually perform in production. Okay. So when we come and do the test ourselves, like compared to the literature, we can see the numbers are dropping. F1 accuracy, all of this, since we are not using the same way that they were using in random split, okay? We call like method. So this is like usually a gap when compared our work with the one of the best maybe results we found in the literature. So these are the key references in our study, and we can say temporal like shift is empirically demonstrable, and F1 like what you can get in random split. If you go to the temporal way, which is more accurate, you can see these numbers will be like much less actually. So maybe this is what motivating authors to go and use a random split just to say we are getting higher accuracy, our models are very good, whatever. But unfortunately, if you go to the temporal test, it will give you much more, accurate results. If you want to consider like these transactions or fraud transactions could be evolved over time, all hybrid models consistently in a consistent way miss the same 13 of 52 fraud cases, suggesting evolved fraud patterns, okay, absent from the training data. And random forest trunk showing reflect that the data set that we are using, it's a flat, non-sequential structure, not a general weakness of the deep learning. Uh, so limitation like single data set that we use, CCF, like no formal, maybe significant testing, drift inferred indirectly rather than directly quantified. The drift happens, and thank you, and I hope it was clear. So this is what I was trying to see in this study, just to make sure, like literature, I was like surprised how these papers are getting high accuracy level, most of the papers, but later when you go and do the testing yourself, use not like using a random split, which we explained, you go and use the temporal way. This way, it will give you much more accuracy, and you can see the most of these even still like models, they are falling behind. Like what you can see on the papers, and you cannot like find these very high accuracy numbers. So I hope it was interesting for you. Thank you, and I wish if I could like join you in real. But subhanAllah, it was like not possible to join the conference. Thank you and salam alaikum.